Hello and welcome to this Python tutorial. So in the previous tutorial, we imported the mall dataset with pandas, and we prepared the x variable, which contains our two columns of interest, the column annual income and the column spending score. So as you can notice, so far we did exactly the same thing as in k-means. And you're going to see that in this new step that we are about to do right now, we are going to do the same action plan. Because remember, when we used k-means in the previous section, at this stage we used the elbow method to find the optimal number of clusters. And here in hierarchical clustering, this new step also consists of finding the optimal number of clusters, only this time we're not going to use the elbow method, we are going to use the dendrogram. So let's do this. Let's plot our dendrogram for this business problem. And then we're going to have a look at our dendrogram, and we're going to use the method that Kirill explained in the intuition section to find this optimal number of clusters. So here we go. Let's introduce a new section here with the comment using the dendrogram to find the optimal number of clusters. And let's immediately write the code to plot this dendrogram. Okay, so the first thing we're going to do is to import SciPy. SciPy is an open source Python library that contains tools to do hierarchical clustering and build dendrograms. So to import SciPy, we're not going to import the whole SciPy library. We're going to import the tools that we are interested in to build our dendrogram. So we type import scipy.cluster.hierarchy. So that's all the part of SciPy library to do hierarchical clustering. And to simplify this huge name, we're going to call it SCH. That will be more simple when we use it afterwards. Okay, so now we have everything we need to build the dendrogram. And now the awesome thing is that we are going to be able to build our dendrogram with only one line of code. So let's immediately write the single line of code. We start by creating the variable dendrogram equals, then SCH, which is the shortcut for SciPy cluster hierarchy, dot, and then dendrogram, which is actually the routine that makes all the process that Kirill explained in the intuition section. And in parentheses, we add SCH dot linkage. So linkage is actually the algorithm itself of hierarchical clustering. And then in linkage, we have to specify on which data we apply the linkage. So that's x, that's our first parameter. Then comma, and then as a second parameter, we add the method. That is the method that is used to find the clusters. And we are going to choose the ward method. So here we write method equals ward in quotes. So what is this ward method? It's actually a method that tries to minimize the variance within each cluster. Remember in k-means when we were trying to minimize the within cluster sum of squares to plot our elbow method chart? Well, here it's almost the same. The only difference is that instead of minimizing the within cluster sum of squares, we are minimizing the within cluster variance. That is the variance within each cluster. And that's it. With this single line of code, we managed to build our dendrogram. It's not like in the elbow method when we had to make a for loop. Here, with only one line of code, we managed to build our dendrogram. And so now we're going to give it a title, a name on the x-axis, and a name on the y-axis. And let's see what happens. So we add here plt.title, and let's choose the title dendrogram, plt.xlabel, and in parentheses customers, because on the x-axis are going to be all our customers. And then let's give a label to our y-axis by typing plt.ylabel, and we're going to put Euclidean distances, because actually the vertical lines in the dendrogram are the distances between the clusters, that is between the centroid of the clusters. And then of course we add plt.show parentheses to specify that our plot is done and ready to be displayed. Okay, so now let's cross our fingers and hope that it's going to work. That is, that we're going to find the same result as we found in k-means, which, if you followed the k-means section, was an optimal number of 5 clusters that we had found with the elbow method. So let's select this whole code section, Command or Control plus Enter to execute. And here is our beautiful dendrogram. Okay, so let's describe this tree. At the bottom we have all our customers, and the vertical lines that we see on this dendrogram are the distances, the Euclidean distances between the clusters. And this dendrogram represents all the different clusters that were found during all the hierarchical clustering process that Kirill explained in the intuition section. And right now what we want to do is to find the optimal number of clusters. So how do we do that? We look for the largest distance that we can make vertically without crossing any horizontal line. And we can clearly see that this largest distance is right here. That is, I start from here, and then I go down, and by going down I make sure I don't cross any horizontal line. Okay, go down, no horizontal line, go down, and then suddenly I cross this horizontal line. So finally, from here to here is the largest distance I can make without crossing any horizontal line. And now to find the optimal number of clusters, we just need to count the number of vertical lines in this space here, and that is 1, 2, 3, 4, and 5. Perfect, so that's exactly the same result as we obtained with k-means with the elbow method, so we're very happy and we can move on to the next step. And remember, at this stage with the k-means algorithm, the next step was to fit the k-means algorithm to our data X. And here it's the same again. Since we just found the optimal number of clusters, our next step will be to fit the hierarchical clustering algorithm to our data X. And this is what we're going to do in the next tutorial. So I look forward to seeing you there, and until then,